In this video, we're going to look at how we can identify the x and y intercepts from a polynomial equation. So we're going to do a little bit of review first. Recall that general form or standard form for a polynomial, specifically here a quadratic function, is something like f of x equals x squared plus 5x plus 4. So this is that ax squared plus bx plus c. And then if we were to factor that, our factored form would look like this, where we've got a factor of x plus 1 and a factor of x plus 4, because 1 times 4 is 4, and 1 plus 4 gives us 5. So these two things both represent, or these two equations both represent the same graph, but they tell us something different about the graph. Recall the general form gives us the y-intercept with our c value here. So this tells us that it has a y-intercept of 4. Factored form helps us find the x-intercepts, and we would set each factor here equal to 0. So x plus 1 equals 0. When we solve for x, we get negative 1. And it's just usually kind of the opposite of the number there. So negative 1 plus 1 would give us 0. So we're looking, that's what we're looking for. So x equals negative 1, and then also x equals negative 4. So if we look at that from the graph, get rid of that. So the y-intercept we see is a positive 4. The x-intercepts were negative 1 and negative 4. So as long as we're able to factor our equations, or if we're given factored form, we can easily find the x-intercepts. So looking at some other examples of polynomial functions that have larger degree, these are in factored form, and we want to identify the x-intercepts and y-intercept. Notice that these ask for the x-intercepts, plural. This asks for the y-intercept, singular. So any polynomial function, you could have several different x-intercepts, but you're always only going to have one y-intercept. If you have more than one, then it's not a function. Okay. So factored form, that tells me or helps me with the x-intercepts. So we've got x-intercepts of positive 1, and I'll just list them out rather than writing the ordered pairs. This would give us a negative 1, and then this would give us here a positive 2. Okay. Now the y-intercept, that is what we find from our standard form or general form. So let's go back to the previous example here. Our y-intercept here was 4. Well, if we look at our factored form, that's actually the product of these two numbers here that we have in our factors. Remember that our y-intercept always has an x value of 0, so we just plug in 0 for x, and 0 plus 1 is just 1, 0 plus 4 is just 4. So we're basically multiplying this number that's in each factor by one another. So over here, plug in 0 for x here, we basically end up with negative 1, positive 1, and negative 2. We also have a 2 here. So to find the y-intercept, we don't need to write it in standard form and multiply all this out. We can just multiply each of these numbers. And that works because when we plug in 0 for x, that's all that's left. So 2 times negative 1 is negative 2, times 1, still negative 2, times negative 2 is a positive 4. I'm actually going to rewrite my x-intercepts here. Okay, so there are my 3 x-intercepts here because I have 3 factors. And here's my 1 y-intercept, which is a product of these numbers. All right, go ahead and pause and give this one a try. So in this example, this is also a third degree polynomial because we have an x here, and then this is x squared, or x plus 2 times another x plus 2. So there's technically 3 factors, but there's only 2 x-intercepts because this factor is squared. So we see the same factor twice, and that just means it's a double root. So that tells us that what the behavior is on our graph when is near that x-intercept. So I only see two factors here. That gives me two x-intercepts of positive 3 and negative 2. And then for my y-intercept, recall that we have to multiply all these numbers here as if we were substituting 0 in for x. Well, this is x plus 2 squared, or x plus 2 times x plus 2. So I have to do 2 times 2, or 2 squared. So that gives me 4 times negative 3 is negative 12, times this is basically negative 1, makes it a positive 12. Okay? All right. In these examples, we have to factor first and then find the x and y intercepts. But because it's already in standard form, we want to take that information, just make it easier on ourselves, and use those to get the y-intercepts. And then once we factor, use those to get the x-intercepts. So pause, give these a try. So this first one we factor and we get x minus 4 times x plus 3. That gives us x-intercept of positive 4 and negative 3. And then our y-intercept we take from standard form. That's our constant, negative 12. Over here, we've got this constant of negative 6, so that gives us our y-intercept. Then we need to factor. We got to be careful because a is greater than 1, so we have to think carefully about how we factor that. And now we get an x-intercept of negative 2/3 for this one. Okay, so it's the opposite of plus 2 with times 3, so it's negative 2 divided by 3. And then here we've got a positive 3, and those are two x-intercepts there.